architect team. We build the pipelines that build the software. And today I'm going to talk about event-driven CI/CD pipelines. I talk fast, so I'm sorry ahead of time. There's a section in this where I'm going to go over a whole bunch of terms, and pay attention to the terms because I'll start using them as we go along as this thing gets more and more complicated. And you guys can boo if you want. So, all right, the software supply chain at SaaS. Let me learn how to run a slide deck. So let's talk a little bit about our software supply chain. Unfortunately, I have to go through a little bit of history so you understand some of the choices we made. I work for an ISV, an independent software vendor, and we deliver software to the customers still, like old school. Like I put it in a box, shrink wrap it, carry it over. Not really, but close enough. So we do RPMs, DEBs, OCI containers on several architectures. And we have a pipeline that builds it, tests it, stores it, and eventually allows us to ship it to customers. So before CI/CD events, we had a tractor. I mean, a very old style pipeline. So we go back to 2015, and our team was tasked with building out a pipeline to produce RPMs for bare metal installs for a new product. At the time, we had a regular software supply chain built around Jenkins and Garrett. That was your chance to boo. And over the course of a few years, we built out a templated packaging system and an asynchronous task engine for building and packaging the software. And I know what you're thinking. Why did you build out a templating system? Well, I didn't think getting 1,000 developers to write thousands of spec files for RPMs was going to be a good idea, and I didn't think it was going to end well. So we built out a templating system that writes spec files, and it's data-driven. So why did we build our own asynchronous task engine? We go back to the year, it's 2015, Kubernetes just was not ready. If we did it again, we might do it with Kubernetes, but Kubernetes doesn't solve everything. We leveraged Pulp, which is a Red Hat technology that they use to deliver their RPM content. It backs up satellite. And that's our repository technology. We have an instance Artifactory that we stuff stuff in, mainly Java stuff and things. And then we built out our own metadata service to track all the units relationships. And so when I say units, I'm talking about like an OCI image that we deliver to a customer. We got 200 and some of them, right? And so that's a unit. Over time, we expanded the package system to build all kinds of stuff, right? So this is the packaging system. It's pretty complex. We're not here to talk about packaging systems. So why did we go event-driven? So in 2019, our CTO came to us and said, I want full CI/CD. And I said, okay, awesome. Panicked, went in the dark room for a while like Aaron Rodgers, and then came out and said, okay, so now we could have chained together a bunch of thousands of Jenkins jobs and got where we needed to be. But I'm not a fan of Jenkins, and I wanted to do something that was not tied to the specific CI. Why did I not want it tied to the CI? Because eventually, you need to migrate to a newer CI technology. And if your event-driven system is tied to your CI technology, it's considerably harder to migrate. So you end up supporting both CI and event systems for a while. Because if you have a new pipeline, you have two pipelines. So we had to make some decisions on the tooling. So we go back and I said, we got Jenkins and we got Garrett, and I've got freeform Jenkins jobs, I got pipeline Jenkins jobs, and it's all a bunch of groovy that runs shell scripts. So problem number one, I had to keep shipping software. Problem number two, we had to invest several years in our current pipeline. We invested several years in our current pipeline. And so the question became, how do we add events to our current pipeline without starting over, right? We can't just build a new pipeline. We got to figure something out, right? So we had a multitude of CI, we still have a multitude of CI tooling and services we wanted to tie into the system. Special clients are a pain to distribute, right? So we needed to be able to bolt events onto the current pipeline. There was a need to be able to create events with tools that were readily available, like curl, Python, Go, Groovy, Java, etc. There's no Java in my pipeline. So we let the services handle talking to Kafka so that the legacy pipeline just needed to post to the service, right? And the decision was made to use JSON for the messaging because it was better than Avro, which is just hard to pull off with the tooling that I mentioned, and I never want to see another XML RPC server again any day in my life. Anybody of you worked on one of those, you know what I'm talking about. All right, so this is the section where I get to some of the core concepts of the system, and we're going to talk about actions, receipts, gates, and stages. And so during the lightning talk, you heard me talk about these, so now we're going to go a little deeper into them. So actions are the task you run to accomplish a result, right? So the examples of an action would be, I ran the unit tests, I built the binary, I ran the functional tests, I ran the integration tests, they failed, I ran the integration tests again. And all these actions produce receipts, right? So the receipts are our audit trail, right? They record all the information from the action. Receipts are JSON. We use Cloud Event Spec for the envelope, and we use CNAB for the custom data section, the payload section. I'll get to why those were not the greatest decisions later. Receipts have an identifier built into them that tells us whether the action passed or failed, right? And we struggled to name this because we wanted it to be a Boolean, and we wanted it to be true or false, and there'd be no question whether the receipt passed or whether the receipt failed, so we used multipass. Multipass. Lost in paradise. So now comes the term you've probably never heard before, and if you are familiar with the RPM naming convention, it follows the NEVRA. It's kind of like a NEVRA, which is name, epoch, version, release, architecture. So we ended up with NVRPP, right? And it's the identifier we use for the purpose of receipts, right? It stands for name, version, release, platform ID, and package, right? So for example, I have name of the package is foo, version's 1.0.0, release is some Unix timestamp. The platform ID is AARch64-OCI-Linux-2. A little bit of GNU in there. And the package type is Docker, right? So remember this term, when I say NVRPP, it's the identifier, right? And it's just a pack of strings that we use to line up receipts, right? Okay, gates. Gates represent the action, all right? Receipts, oh, hang on. Example would be, if I had an action to build the binary, I have a corresponding build gate to represent that set of tasks, right? We make receipts for build actions and post them to the build gate. Gates are satisfied by receipts, which track the completion of each gate's requirements. Posting a receipt to a gate results in a message on the Kafka bus. Now we're getting to event-driven, right? So I'm finally getting to this piece. Thanks for staying with me. I'll be here all week. So stages are a list of gates, and then when all the gates in a stage have successful receipts with the multipass true, right, then the stage triggers and it emits a message to the Kafka topic, right? Example would be unit test gate, build gate, functional test gate, integration gate. We post receipts to them asynchronously, but once all of the receipts are there and for that NVRPP, that stage fires a message, right? And you know that that event is always true because it won't fire if it's not. So you got gates firing events and you got stages firing events. Everybody still with me? Okay. So where do we store all these receipts and gates and stages? The gatekeeper was the first service we built. It is the central communication point for the system. It's a Go service, Postgres, always use Postgres until Postgres doesn't work, right? It has a GraphQL API endpoint for searching for receipts, gates, and stages by various attributes. Receipts, gates, and stages can never be deleted. They're our audit trail, all right? You can revoke a receipt, regardless if it's multipass, and you can disable a stage so it stops messaging. The gatekeeper is a source of truth, and it is the only service allowed to talk to the main Kafka topics, right? So we lock down the Kafka topic, and the gatekeeper is the only thing that can talk to it. I got no chance of spoofed messages coming to that topic. So what do we do with all that stuff? Okay, so we built these things called watchers. And the watchers listen to the Kafka topic, and they filter on the messages for things they care about, right? So you could have a watcher that's looking for a specific NVRPP, or just a specific name of a unit, and it does an action on every one of those, every time it sees a receipt for that name of that receipt, name of that unit. Most of our watchers written in Go, they run in Kubernetes, then they allow us to trigger actions based on events. So you remember we were doing actions, they produce a receipt, now we've got a watcher waiting for an event and it runs an action, produces another receipt. You can see how this can spin out of control. The second watcher we built, so the first watcher we built registered test containers with our test container registration service. I'll get to them in the next couple of slides. The second watcher we built was a webhook service, and it uses a Go templating language to form a URL based on the data in the event, right? And then it attaches any receipts attached to that event as a payload. And this allowed us to trigger Jenkins jobs based on events and pass data into the Jenkins job. And we use it to trigger non-event aware systems wherever we can. And the third watcher we built, the worst watcher we built, was a Jira issue watcher. And now you can understand what I'm getting at, right? It can trigger a Jira ticket creation from an event. And when it posts a receipt, when you go and close that Jira issue, right? And if you, so then you can trigger automation based on human interaction. So the pipeline after CI/CD events. So after we bolted events on here, and I am telling you, we bolted this on, right? With Python libraries and command lines that we wrote, running in shell script, running in Groovy. Oh God. The chain of events all starts with the build. The developer pushes the code. The units builds. The build receipt posts to the gatekeeper. The gatekeeper puts the event on the bus. The watchers catch the event and do things. And they make receipts that create events that drive other watchers. So what did we do next? Well, we decided to wire up our automated test framework. So while we're working on building out this army of watchers, our test team, that's Parth over there, was adapting the test automation to be event-driven. It took us a couple of months, but we eventually had a workflow that was completely event-driven. And we built all the tests into test containers. A test container are containerized sets of tests that test a specific software we ship to customers. So remember when I was talking about units, right? We got a test container that goes with that unit, right? That test container can test multiple units. And we register it with the test container service, and that gives us a list of all of the units it can test. Remember that. Okay, now I'm lost. So when we build the test container, the build receipt event triggers the test container watcher to make gates and new test for the new test container and register the container and its gates and the units it tests with the test registration service, right? So the test automation service does a deployment of all the units. It then talks to the test container registration service to get a list of all the test containers and their gates and the units they test. And it then runs the test containers with injected configuration in batches as Kubernetes jobs. As each test container runs its tests, they record the output of the tests as XUnit. And then each test container contains a tool that converts the XUnit to a receipt with the test count and sets a multipass for the receipt, true or false, based on the results of the XUnit. The tool then posts the receipt for the test containers to the test containers corresponding gate. Remember when I said earlier, when we register a test container, the test container watcher goes and makes a set of gates for that test container, and then the tool posts receipts to those gates as we go. Okay. So this gets even more complicated, and you can see where we've been building on this, right? So how did we incorporate destructive testing into the event-driven system? So we have this amazing event-driven system and driving our automation and the tests that promote our units towards production, and we have a team outside of this framework doing destructive testing, and they want to put the destructive testing into our automated framework. Well, guess what happens when you put destructive testing in an automated framework? You break the framework. It all breaks. So, I mean, we couldn't put it in with the rest of the automation. You can't rip the database out from under the software while you're trying to run non-destructive tests against it. So we set up the teams doing destructive testing outside of the automated framework with their own automation. And their automation is usually kicked off by some event coming from the system, right? Some other watcher, usually the build receipt, right? And then those teams create their own set of gates that represent their destructive testing. And as they run their destructive testing for an NVRPP, name, version, release, platform ID package, they post receipts to those gates with the results from the destructive tests. So what we end up with is a test container registered in with the unit, and we want, let's see, hang on, that's complicated. All right, we have a test container, right, that's registered with the test container registration service, and it runs in the automated framework, and it goes out and it checks the gates for the destructive testing and asks for the receipts for that MVRPP. And if they're all passed, it creates a test in the automated framework, posts a receipt in the automated framework with pass or fail, depending on what it found on the outside destructive testing gates. So what we end, and then so this gets us to destructive testing tied back into the automated framework without destroying the automated framework. So what did we do next? DevSecOps. We decided to automate all of our scanning and tie it back in with Jira tickets and all kinds of other stuff. And that is a talk for another day because I can see your eyes glazing over. If you want to talk about the DevSecOps stuff, we're going to do something at the 345 slide. This is what you guys care about. Lessons learned, right? So event-driven asynchronous systems are really awesome, right? But they've got a huge observability challenge. You got to think about your debugging tools and observability early in the process. A lot of teams have no idea how to debug event-driven pipeline issues. Write your tracing tools early and make them easy to understand. Now, I ask you, what do you think we did? None of that. What we ended up doing is, I lost my mouse. So we found ourselves constantly writing chunks of Python and Go to go figure out what happened, right? Because we're the only guys who understand the system as it is because it's complicated, right? And those tools became tools. The things we wrote became real tools. And then we should have written them earlier, but we wrote them as we ran into them because we didn't know what we didn't know, right? We built a UI based off of the GraphQL API endpoint. It is awesome if you know what you're looking for. And if you don't, you won't find anything. We didn't want to add regex to a problem we already had. Anyway, that brought us to, if I can find my mouse, come on mouse, I need you. All right, so you understand now that the observability is the biggest problem in event-driven, right? It's asynchronous, you never know when something's finished, build your tools early, right? Schema, I'm gonna lump two things together here for the sake of time, but if you use JSON or if you use XUnit, write a schema and validate it everywhere. Enough said. Let's see. Authentication. So we had originally planned to implement authentication. We started to write an ACL system for the gatekeeper. Andrew did it, and we started on it. And we decided we would just never be able to get done in time, right? We're trying to go from 0 to 100 in less than 8 months, right? And so we figured out that we weren't going to be able to finish an ACL system in that amount of time. And so we ended up with a token-based system. And the token-based system was okay. We could kind of tell who did what. And then the Jenkins jobs all have the same robotic count. And if you don't understand, don't ever put yourself in that spot. Use unique identifiers for each of the clients. Last year, we did put OIDC auth on all the endpoints in the system, and it's made a big difference, and we should have done it from the beginning. Always do security first. Guardrails, they're cool. We should have built some into the system from the beginning. basically you had this box of Legos with no instructions. And guess what happens if you give developers a box of Legos? Nothing cool. They go off the rails immediately. And they're like, what can we do with this? And you're like, ah. First one I'm going to get to is a pretty good story. So I'm going to tell you right now, limit your message size, right? When you're doing your events, right, the event is not a data stream. Kafka will tell you it's a data stream. Don't listen to them. They're lying. You want an event that is concise, tells you what it needs to do, and has URIs that point to the data, right? So the first time, so the default message size on Kafka when we did this was about 1 megabyte. And we had a developer, and he was developing a watcher, and great guy, super smart. Remember I said the gates produce events, right? And this watcher's got this gate, right? So he's got this watcher with a gate. This gate produces this action, and he's filtering on that action. So every time he posts a receipt, he forced himself to print another receipt, and another receipt, and another receipt, another receipt, and he fork bombed himself into 97 megabytes. So at that point, we decided that we had to put a limit on the size of the receipts, as well as the events, and we decided on 1 megabyte, and it made some people unhappy, but no more fork bombs. So the fun fork bomb incident prompted us to, in the watchers, put a test to make sure you weren't posting to the gate that you were watching, or that you weren't watching the gate that you were posting to. All right, rate limiting. Let's go into rate limiting, right? So rate limiting is important. So our promotion watcher goes down on a Saturday, right? And it's down. And our automated testing did not go down. And so the automated testing is running, producing all these promotion events, right? Here, promote my unit, promote my unit, promote my unit, promote my unit. We're up in the thousands. So we come in on Monday, and we're like, Kafka consumer groups are really cool. We know where we left off because our watcher crashed. Let's just fire it back up. Well, the promotion watcher had no rate limiting on it. So it proceeded to DDoS everything downstream. It kept up for a little while, and then things started to fall over, and they died, and they crashed, and then we get alarms coming in, and people are like, hey, what are you guys doing over there? I was like, no, what is it? Anyway, so we had to shut it down, and we had to start over. So had we had rate limiting on the promotion watcher, we probably wouldn't have run in that. I still don't think we have rate limiting on it. We just don't try and replay thousands of events anymore. Last couple of things, sanitize your inputs. I cannot stress enough, sanitize your inputs. Within the first 2 days, I had a developer try and base 64 binary and stuff it in a receipt on me. Because if you've got a database and you have devs, they're going to try and turn it into a blob store. Just end of story. Sanitize your inputs, okay? I did promise I was going to go over the CNAB, but I'm getting flagged for the 5-minute thing, so I'll be quick on the CNAB. If you don't know what the CNAB is, go look it up. It's a spec for cloud bundling, cloud native application bundle. And there's this tooling around it, and then the idea is you've got this piece of JSON, and the tooling can run stuff based on that piece of JSON. So you feed the JSON to the tooling, and it runs. So we took that and made it the payload of the receipt, right? With the intent that when we ran the actions, we would, and we need to rerun them, we would go grab the receipt, take the CNAB section out, and hit it into the tool, and it would replay the events. That was lost on every developer except for me. So we didn't really ever implement that. Basically, we ended up using the CNAB as another section, and then we took the custom section of the CNAB, and that's where we put all our proprietary metadata. So it's a blob store for proprietary metadata. And we're stuck with it for a long time. So anyway, pick your specs well. All right. Had we only. So the things I wish we had done is I wish I had cryptographically signed the receipts. Had I done that, I'd be halfway done with my salsa provenance journey, and I wouldn't be trying to figure out how to create provenance. I'd be done. RBAC service. I wish we had written an RBAC service for the whole pipeline. We still may, because I want to be able to control access to the pipeline pieces based on role-based actions, so that Tom over there can't talk to can't go use the pieces of the infrastructure he doesn't need to be using that Parth uses. So that's what we're trying to shoot for there. Tom was involved in the whole rate limiting thing. So things that went well. We increased our performance exponentially without having to rebuild the old pipeline. So it used to take us a week, 2 weeks to get a unit update to the customer. We can do it in 8 hours. Testing automation increased our confidence in our quality, our software, and the security automation decreased our time to remediation. The framework continues to allow us to quickly create event-driven automation for any set of tasks we need. Billy uses it all the time. So some quick things that I want you guys to check out. Go to the CD Foundation. They've got this CD event spec. If I had the CD event spec, I would have used it instead of the CNAB back when I was doing this. All right. From the lightning talk, hope's not a strategy. Electric sheep harm 0. Receipts, gates, and stages are done. Everything gets the receipts mostly done. Robots promote the units is done. My letter to Deckard's written. Automatic, not just automated, is mostly done. Reproduce actions from receipts is not quite how I wanted. You guys heard the story. We can trace the life cycle of the binary. Machine learning we didn't get to, even though we should. Predictive test selection we haven't gotten to, and deployment risk prediction, and I'm still afraid of robots. So I'm Smitty. I'm afraid of robots.
That was awesome.